Alright, last video of the week here. Same kind of thing. We've been through compressional beam testing, we've been through dual element, we've been through delay line. Now just one more shot at it here. I'm going to lay this block down for just a minute. We're going to do calibration for shear wave testing, and then we're just going to try a shear wave weld plate here, or at least try a weld plate. Okay? This is a specially made weld plate, so we know there's defects in it. But we just want to see here how it actually works. So we're going to go this route first. Okay? I'm just going to hook up my shear wave block. Going to put some coupling between the transducer and the block. So put a little coupling on it here. Let me get some more. We got a little coupling there, which is probably not enough. So let's just put a little more on there. Doesn't take a lot, but we want to be able to put the coupling between the block and the wedge here. Then you'll see it squeeze out, which is what we want. So we know we got plenty of coupling in there. Alright, now we've got transducer up here, compressional beam transducer, shear wave wedge down here. And with that shear wave wedge, what we have is a beam exit point or a beam index point. This is up here to help burn up the longitudinal beam when it reflects out. And then here's our surface, or here's our surface. We're going to have the refracted shear waves down in here. So, before we ever hook the transducer up, I'm going to take my range up to 10 inches. Okay? My material velocity down to shear wave, which if I push that again I could do that. We're going to be right in here between one of these two. If I'm remembering right, it's going to be about right there. And then we'll bring our probe delay all the way back to 0. There's our initial pulse. Here's our hookup. Just going to hook this guy up so we know it's alive. Okay? Maybe. There we go. Alright. Here's our IIW block. This is a IIW Type 1 reference block, meaning we're going to need to see signals at specific distances. On this one, we're going to need to see a signal at 4 inches, because from this 0 right here to there is a 4-inch radius. Okay? And then from this 0 right here to this radius is 1 inch. So what's going to happen is we're going to put our transducer on here like this. Sound's going to come down, going to bounce off at 4 inches. Okay? Some of it's going to be reflected back, some of it's going to continue on. So then it's going to add another inch, but the sound's going to be coming up this way, so transducer can't receive it if it's pointed this way. So it bounces and goes back down, comes back, and then we pick it up again at 9. So 4, 9. First signal at 4, second signal at 9. Looks like we still got a little coupling on the block because we got a couple signals already. Alright, so just distance is all we're doing right now. Just basic shear wave distance. We don't really need to do anything for complete calibration yet because we're not ready for that yet. You just need to see the distance stuff. So, just taking a gander here, I parked my transducer right over the 0. Got a signal here and a signal over here. Well, I know I need that signal at 4 inches, so I'm going to take my delay and push that signal over somewhere near 4 inches. Okay? I'm going to bring my gain down a little bit so I can see the top of that signal, because I want to move this back and forth and peak that signal out. Okay, so there it's pretty much peaked out. And that is what I want to control my calibration off of. So I'm going to back it up just a little bit. And now I should have a signal over here about 9. If I bring this over a little bit, that helps it stand out a little more. Bring up my gain. I'm pretty close to 9. Okay, here he is right there, this signal up here. And I'm going to take my velocity, or fine range, and push it over to 9. Okay, when I did that, my 4-inch got off a little bit, so I'm going to bring it back. Okay, my 9 inches off again just a little bit, so I'm going to push it back over. Okay, we're getting close. I'm going to bring my probe delay back just a little bit. And that's going to work for us. So now, here's my gate. I'm going to raise this up to about 40% screen height. And I'm going to bring it over to where it touches that signal. Okay? Now if you watch this sound path, that SA, it's going to walk on us because I'm moving the transducer back and forth. So 4.283, 3.800 basically. I'm going to put him right on 4 inches. Okay, and I'm going to do the best I can to not move this transducer. And then I'm going to take my gate again and move it over here over the other signal. But since it's not up to 40%, I'm going to drag it down a little bit, and it's going to tell me I'm right at 9.011. Okay? Which means I'm pretty close to 4 and 9, which I can see on my screen here, and you can see too that I have a signal over here. Here's 10, 20, 30, 40, so there's 4 inches on a 10-inch range. 50, 60, 70, 80, 90%, there's 9 inches on a 10-inch range. There's my material velocity, display delay, probe delay. That let me move these back and forth. Okay? Now granted, I haven't done any sensitivity calibration or anything. That's just distance, 4 and 9 inches. So now, I'm going to bring my weld plate over and I'm just going to look for a defect. Okay? Haven't done any sensitivity calibration again, anything like that. So I'm just going to add 6 dB here. Okay, now granted, industry people will tell you that's not the way to go. I realize that, and I'm saying that because I have not done a sensitivity calibration. Alright, so this plate, he's probably about, 3/4 of an inch thick by the time it's all said and done. Here's a 1/2 inch. It's between 1/2 and 3/4. So 625 or so. So 5/8 of an inch thick plate. Okay, put a little coupling on here. Granted, I haven't figured out, since we're all here together, I haven't figured out any of my calculations that we did earlier. Okay, and there's still our 1-inch plate up there, but I haven't done any of that yet. So I'm just piddling right now, basically. If I was actually calibrating, they would tell me I'm not completely calibrated, which I realize that I'm not. So, I just want to look here and see. If we were to look and calculate all this out, we would see that we have a signal over here about 6 inches. Okay? Which we know darn good and well that from here, sound wave bouncing down and back up is not 6 inches. So I put a little coupling on the end of my finger. I'm going to go out here, run my finger on it. If you can see, this signal right here, with me rubbing my finger on the edge of the plate, is moving. Okay, so that tells me that signal is coming from the edge of the plate. So now I know, alright, that signal I can really pay no attention to because it's clear out here and I don't really care about out there right now, because that's not what I'm inspecting. So I just want to look at this weld interface here, this weld bead. Okay, I'm going to slap a little more coupling on there. Some people say you can never have enough coupling. So just put a little more on there so I got a little more room to move. Okay, again, edge of the plate. So now I'm just back and forth in here. Raster scanning is what this is called. I'm just looking. Looks like we got something pretty good size right there. Okay, don't know what it is yet because we haven't done any calibrations. So we're just looking. Okay, I'm raster scanning back and forth, up and down. There's that one thing again that we just saw. Okay, if I back off, come at it from back here again. Really don't see it that well. Get close enough up on it. There he is again. I'm going to continue to raster scan here. It looks like we're still catching the edge of it. Got a little something right there, but it really isn't enough to bother us yet because we don't have our gain very high. Raster scanning. Looks like we saw something there real quick, but it might have been just a signal jump from the transducer. Okay, got something right there. Tell we got something right there. It's not very big, at least not with this gain, but we know there's something right there. Okay, and there we are looking at it again. If we get up on him here, there it is again. Okay, that's the edge of it. And then now we're getting back over here to that big signal right there. Whoops. Keep putting a little coupling on the screen every time I touch it. Alright, so we would just measure this out just for fun. Let's peak it up kind of as high as we can peak it. So there we're peaked up. Bring the gain down a little bit to where this is at 80%. Come over here. I'd make a mark right here straight out. Peak it back up. There he is at 80% again. Make another mark right there. That's going to tell me it's about 1 inch long. Okay, and I would actually make marks here so I could see. I just use my finger. So I'm going to run this up. I was at 65 dB. I'm going to run up to 75 dB just for fun. I just want to see what's going on in here. Now you see here, we see the edge of our initial pulse, so that actually kind of hurts us a little bit. Okay, there's that big guy again. There's the edge of it. Okay. Got something right here, that's a little farther over. Alright, that looks like geometry of the root. Maybe not. Yeah, there we go, look at that big old thing. So I'm just scanning here. Get back over here, and right on that side, looks like we got something else right there. So we would come back and test that again to see exactly what we got. Now granted, like I said, we don't know exactly what that is because we didn't do any sensitivity calibration, but at least we can tell, hey, real quick, there's something in there. Okay? Now, just one last thing. That was just piddling on a weld plate. Let's go back to our IIW block. I'm at 75 dB. I'm going to bring that down to where my 4 and 9 signals are manageable. Alright, so there we are on our 4 and 9 signals on our IIW block. Push it back out of the way. Bring in a DSC block. Okay, get a little couplet. DSC block, this is from a 0 point here, 0 here. This is a 3-inch radius out and a 1-inch radius. So if I take this and point it this direction, I should get a signal at 1, 5, and 9. Okay? So look in here. There's a signal at 1, there's a signal at 5, there's a signal at 9. Okay, the stuff that's happening right in front of those two, those are this. The little saw cut in here. So if I turn it this way now, I should have a signal at 3, 7, and 11. Which I do, and again, these little signals jumping out in the front are the saw cuts. So 3, 7, 11, with these little signals being the saw cuts. And that's how you can reference the two between IIW and a DSC. That's just a little side note right there. Alright? Again, questions, comments, concerns, feel free to contact me.